Okay, take a look at this Visual Basic code. Dim score 1, dim score 2. Total equals score 1 plus score 2. I mean, if you're just starting out in programming, this looks totally fine, right? You've set up your variables, you're adding them together. What could possibly be the issue? Well, here is the harsh reality. In a Cambridge Paper 2 exam setting, this exact piece of code is going to score you a brutal 0 marks. Yep, 0. It's an absolute classic trap. To a beginner, it looks perfectly logical, but it's actually hiding a logic error that'll completely derail the whole program. Welcome to this explainer, Arithmetic Operators in Visual Basic Revision Guide for IGCSE Computer Science 0478. Today, we're going to break down exactly how to master these operators, and more importantly, how you can use them to absolutely lock in those top grade boundaries. We're not just rattling off what the operators are, no. We are really diving into how the Cambridge examiners actually want you to write them, test them, and explain them. So let's just jump right in. Before we even think about calculating anything, we have to be able to store it, right? So think of variables as basically the programming equivalent of a scientist taking written notes during an experiment. They are these small, dedicated areas of memory set up right inside your computer just to store data. Any program you write is completely going to rely on these variables to hold values that a user types in, or values that naturally change as the code runs, like a player's score going up every time they beat a level. And that brings us to this massive concept called strong typing. And spoiler alert, this completely solves the mystery of that trap we looked at earlier. You see, in Visual Basic, you actually can technically declare a variable without telling the computer exactly what kind of data is going to live inside it. That's exactly what that opening code did. But Cambridge examiners, and honestly, literally anyone who wants to write good, crash-free code, they demand strong typing. By explicitly defining the exact data type right when you declare it, you're letting the compiler check for mismatches, and it actually makes your code execute a lot faster. It's just an absolute must if you want those high marks. So what exactly are these data types you need to declare? Well, here is your mandatory syllabus-safe checklist. We've got integer for your whole numbers, real for any decimal numbers, char for single characters, string is what you use for text, and finally Boolean for a super simple true or false state. Anytime you declare a variable in your exam, you've got to lock it into one of these specific types to satisfy that strong typing rule we just talked about. Seriously, memorize these. They're going to be your absolute best friends in the exam room. This perfectly illustrates another really strict rule for your variables. You have to use meaningful identifiers. Just take a look at the identifier player1 high score. You instantly know what that memory area is doing just by glancing at it, right? But notice the specific formatting here. It is literally impossible in Visual Basic to use spaces in your identifiers. So to keep things readable, we use this trick where you start each new word with a capital letter. It seems like a tiny detail, but this simple trick makes your code infinitely easier for you to debug and way, way easier for a tired examiner to read and actually award you marks for. Okay, so we've got our variables correctly typed, they're named perfectly, but here is a really critical question for you to think about. What is this single examiner clue that changes a calculation question completely? It is a trap, and it honestly trips up thousands of students every single year. But actually, hold that thought. Before I reveal what that is, let's quickly look at the basic mathematical toolkit that makes the answer to this incredibly obvious. To actually do anything with those variables, you're going to need your arithmetic operators. You've got addition using the plus symbol, subtraction with the minus, multiplication using the asterisk, and division using the forward slash. But I want you to notice a really crucial pattern here. The result of the calculation is always stored back into a new variable on the left side of the equal sign. This right here is the core mechanism of data processing in all your exam algorithms. The math happens over on the right, and the memory stores it on the left. Now, once you've done all that math, your job still isn't over. Why? Because users will inevitably find some spectacular way to completely break your program. I mean, they literally always do. Paper 2 dictates that you absolutely must test your logic rigorously. So you have to know the difference between normal data, which is stuff that should be accepted perfectly, abnormal data, which needs to be immediately rejected, boundary data, which tests the very extreme edges of your accepted limits, and extreme data, which just falls way outside those normal limits entirely. Just remember, testing your code is just as vital as writing in the first place. And that brings us right back to that examiner clue I teased a minute ago. The big secret? It lies in the Cambridge command words. You have to carefully match these to make sure you're not just leaving easy marks on the table. Like, if a question asks you to state or define, they are looking for a concise, distinct technical point, nothing more. But if it says calculate, you absolutely have to show you're working. The command word dictates the exact depth and style of the answer that the examiner is waiting for. If you ignore it, you're basically answering a question they didn't even ask.
So the really crucial point here is how you structure those deeper, longer answers, especially when that command word happens to be explain or evaluate. Don't panic when you see those. Just use this simple 4-step answer template. Honestly, think of it as a cheat code for full marks. Step 1, start with the core concept. Step 2, grab a direct example straight from the scenario they gave you. Step 3, explain the consequence or the advantage of using it. And Step 4, wrap the whole thing up in precise examiner wording. Using this framework practically guarantees you're hitting every single point on those tricky high-mark algorithm questions.
Okay, let's bring this whole thing full circle and finally fix that trap from the very beginning. That flawed code, it fails miserably simply because it lacks strong typing. The computer has no idea what kind of data is supposed to go into score 1 and score 2. But just by adding as integer to the declaration, we instantly upgrade a total 0-mark disaster into a mark scheme safe, top-band piece of code. The compiler now knows exactly what to expect, and more importantly, so does the examiner. As we start to wrap up this analysis, I want you to basically write this golden rule in stone. Apply every single answer to the scenario nouns and constraints. Seriously, never, ever give a generic textbook definition if the exam question is specifically asking about, say, a hospital database or a school grading program. You absolutely must apply your properly typed variables and operators directly to those specific nouns and constraints to secure the full marks they're offering. Context is quite literally everything. All right, so you fix the code, you fully understand strong typing, and you know exactly how the examiner's logic works. If you're wondering how to map all these concepts into a strict 7-day revision plan, make sure to check out our YouTube channel, Ace the Exams, at acetheexams_IGCSE. But before we sign off, I want to leave you with this one provocative thought to chew on. The next time you sit down to write a line of code in an exam, are you writing it for the computer to understand, or are you actually writing it for the examiner to award you marks? Think about it.